Hi, this is Mrs. Marita. Welcome to section 5.4. This is part 2 of our absolute value function and graph lesson. This one is focusing on horizontal shifts. All right, let's turn to page 112 in our student companion book. Just recall the function for an absolute value graph is written as a times the absolute value of x minus h plus k. In section 5.1, we learned about how a affects our graph. If a was a fraction less than 1, our graph was going to be wider. That represented the slope of the two lines. If our a was larger than 1, then we would have a more narrow graph with steeper slopes. And if a was negative, that told us we needed to flip our inequality, and it would open down. In 5.1 part 1 of our lesson, we talked about k. This is our vertical shift. K would tell us if we need to shift our vertex and the rest of the graph up or down. Today's lesson, 5.4 part 2, is going to talk about our horizontal shifts. That's going to be our h, and this will tell us how far left or right we need to shift our graph. For example 3, now we're going to study our horizontal translations of our absolute value function. This is when our h is changed, and we're going to shift left or right. Again, for each function, we want to identify the vertex and the axis of symmetry. For part A, our function g of x is equal to the absolute value of x minus 3. So in this example, our a is 1, our h is 3, not a typo. Recall our parent function, f of x is equal to a times the absolute value of x minus h plus k. This is kind of weird. There is that built-in negative. We saw this with some of our linear functions before. So when there's this built-in negative and we have a negative in the given function, our h is going to be that positive 3. And then last, our k in this example is 0. If we want to do a quick sketch, again, our parent function, over 1 up 1, over 2 up 2, what we're going to do is shift everyone horizontally 3 units to the right. And so our new function will have a vertex over 1, 2, 3, and then over 1, up 1, over 2, up 2. This isn't a formal graph, just a little quick sketch. And so our vertex is right here, and our axis of symmetry would be going down the center. So when we write that up, we'd say our vertex is that point hk, so 3, 0, and then our axis of symmetry is always x equals h. So in this example, x equals 3. And then for part B, our function now is p of x is equal to the absolute value of x plus 5. And so again, our a is 1, but in this example, your h is negative 5. If it helps, you can visualize this function as the absolute value of x minus negative 5. We need to think about the function with that negative as the part of the formula. And so to get a positive here, we must have a negative and a negative. Negative times negative, we get our plus 5. And so our h is just the negative 5, and k again is 0. In this example, we would shift our graph 5 units to the left. So our parent function, we just have those basic 5 points, and then we're going to shift everybody over 5. And we're going 5 to the left, 1, 2, 3, 4, 5. That's my new vertex. And then all of my other points would shift over 5 as well. And so I'd have my vertex and my axis of symmetry. So let's write that up. Our vertex would be hk, so negative 5, 0. And our axis of symmetry is x equals h, so x equals negative 5. And that's it for section 5.4, part 2. There's going to be one last part 3 to this series of lessons. But for today, make sure you copy down all your notes and bring your questions to class.